Hi everybody, in this video I'm going to go through our parallelogram properties and what we're going to do to start off, I'm on the page, is list out our basic parallelogram properties. So first thing I'm going to do is actually draw an image that we will reference here. So we are going to have a parallelogram kind of looks like a slanted or a pushed rectangle. This will be my parallelogram A, B, C, D. So our basic parallelogram properties, hopefully we all know that in a parallelogram, opposite sides are parallel. So I can conclude AB and DC are parallel segments, or CD, however you want to look at it. And I can say that BC and AD are parallel segments. So BC parallel to AD. That is kind of the basic definition of a parallelogram. Also, in a parallelogram, opposite sides, not only are they parallel, but they are congruent. So AB is congruent to DC, and BC is congruent to AD. So AB is congruent to DC, not just parallel, and BC is congruent to AD. This also means that their measures, the distance between AB and DC, is equal or equivalent, and the distance between BC is equal to the distance between AD, right? Those two lengths are the same. We have congruent segments, their measures are equal. So that talks kind of about their sides. Let's kind of talk a little bit about their angles now. So opposite angles are congruent. So just like opposite sides are congruent, opposite angles of a parallelogram are congruent. So I know then that A and C, which are opposite angles, are congruent. Oops. And I know that B is congruent to its opposite angle, D. Not only are opposite angles congruent, we also, in a parallelogram, can determine and figure out, prove that consecutive angles are supplementary. And remember, supplementary means adds to 180. 180 degrees, that is. And what's a consecutive angle? Consecutive angles share the same side. So A and B are consecutive angles along this shared side AB. So angle A and angle B are consecutive because they sit along the same side. Because these angles are consecutive, they are supplementary, which means the measure of angle A plus the measure of angle B is 180 degrees. And this is really because of the same side interior angle theorem. We know that BC and AD are parallel. And so this pink line, AB, is like a transversal with these two same side interior angles then, which must add up to 180 degrees. We have other sets of consecutive angles that add to 180. The measure of angle along the bottom, A, plus the measure of angle D, has to be 180 degrees. Working on the other side, the measure of angle D plus the measure of angle C would have to be 180 degrees. And along the top, the measure of angle B has to be supplementary to the measure of angle C. Those two together also have to be 180. Okay. The last property I kind of want to talk about is going to get its own diagram. And let's draw that first. So I'm kind of just going to recreate our parallelogram. A, B, C, D. And we're going to talk about the diagonals. And the diagonals of a parallelogram bisect each other. So the diagonals go across our shape between opposite vertices. So AC and BD are the diagonals. AC and BD are diagonals. So they bisect each other. So AC bisects BD, which means that at this intersection point, we'll call that point M. Since it's bisecting, AC is bisecting BD, these two congruent halves, or these two halves here, BM and MD, they are congruent. So BM is congruent to MD. AC bisects BD, and BD then oppositely bisects AD. So BD cuts AC into two congruent halves. So BM is congruent to MD, and AM, oops, and I was missing my segment bars. It kind of looked like I was missing something. AM is congruent to MC. I also know if I add up these two halves segments, it would give me the whole diagonal. So BM, the measure of BM plus the measure of MD is equal to the entire diagonal BD. And the measure of AM plus the measure of MC is equal to the entire diagonal AC. Let's look at some examples. Number 1, in parallelogram, WXYZ. I'm going to write my Z's like this so they don't look like a 2. The measure of angle X is 76 degrees. Find all angle measures. So we know one of them. Essentially, we need to find the other 3. And we don't get a picture with this, actually. So we're going to draw one, and I'm going to draw kind of a different looking parallelogram. Still going to have all the same properties. It just doesn't look like the first 2 I drew. So this is parallelogram W, X, Y, Z. Notice how I just followed those vertices in order around. We know X, right? The measure of angle X is 76. Which means I can figure out this opposite angle, right? Angle X is congruent to angle Z because they are opposite angles. And opposite angles are congruent. So since angle X is congruent to angle Z, the measure of angle X is equal to the measure of angle Z. And since we know X measures 76 degrees, so does Z. So Z is also 76 degrees. So that's one of our angles that we needed to find. Next, we can rely a little bit on what we know about consecutive angles. So I know that angle X, and I'm going to pick angle Y. X and Y are consecutive angles, meaning they lie on the same side. Right? They lie on the same side, X, Y. So if I want to find this angle measure, I can take the measure of angle X and add it to the measure of angle Y, and I know that they have to add to 180 degrees altogether because consecutive angles are supplementary. We know the measure of angle X, right? X is 76 degrees, and we're going to add that on to the measure of angle Y to find that they add up to 180. And I can now subtract 76 from both sides and find that the measure then of angle Y is 104 degrees. So Y has to be 104. And finally, if we know Y is 104, I can figure out then that W also has to be 104 because angle W is congruent to angle Y. These are more opposite angles, or the other set of opposite angles. So my measure of angle W is equal to my measure of angle Y, and Y is 104 degrees. So the measure of angle W is 104 as well. All right, now we found all of our angle measures, right? We know X is 76, Z is 76, and then both W and Y are 104. Number 2, in parallelogram, I feel like I wasn't even holding it there for that long. Parallelogram. Ah, A, B, C, D. AB is equal to X plus 20. DC is equal to 3X and AD equals X minus 2. What is the measure of, or the, I'm going to say, what is the length of BC? And we need an image here. Here's our parallelogram, A, ooh, B, C, D. And this image, or when this problem, when I looked at it for the first time, it didn't have any labels on it. It was just A, B, C, D like this. So I would start filling in the side lengths I know. I know AB is X plus 20. I know DC or CD is 3X. And I know AD is X minus 2. We want to find this unknown length BC. And right now, I actually know, so I know a couple things about this parallelogram. First of all, I know the opposite sides are parallel, but the opposite sides are also congruent. So AB is congruent to DC, and AD is congruent to BC. So that is going to be something very helpful because I know then AB and DC have to be equal, and we know those two things, right? We know AB and we know DC. AB is X plus 20, and DC is 3X. AD, I know is x minus 2, but if I can figure out then what x is, I could substitute it in for AD and then maybe figure out what BC is. So let's now solve for x. Solve for x. So first I need to get x on one side. So I'm going to subtract x from the left-hand side, move it over to the right. So that way I'm subtracting 3 minus 1x, which is just 2x. So I have 20 is equal to 2x. And then I can continue to solve for x. I would divide both sides here by 2. So 10, because 20 divided by 2 is 10, is equal to x, or x is 10. Now we know that AD is equal to x minus 2. So I can substitute in 10 for x, right? If x is equal to 10, I can say then that AD is 10 minus 2. Subtract x minus 2, and 10 minus 2 gives me 8. So AD then is 8. Which means that BC also has to be 8. Because AD is congruent to BC, we know their measures have to be equal. So BC also equals 8. All right, I want to do one more problem.